Welcome to the deep dive. Today, we're soaring into a really exciting bit of tech. We're talking about high-performance drone building. We've been listening to this great chat between a couple of drone builders, real enthusiasts, and it wasn't just about, the parts list. It was digging into why they chose certain things, the problems they hit, and how they figured stuff out. Our mission here is to unpack those specific parts, figure out why they matter, and understand what makes these machines fly so incredibly well. Or, crash in style.
Exactly. And it's more than just the components in isolation, right? It's about the synergy, how everything has to work together. That's what we're pulling out of their conversation, the thinking behind the build.
Okay, let's get into it then. Starting with the absolute base, the frame. They were talking about a 5-inch carbon fiber frame, praised it for being, well, super light, but also really tough.
Yeah.
How vital is that specific combo? I mean, what if you go too far one way or the other?
Oh, it's critical, especially for these high-performance builds. You see, the frame isn't just holding things together. It's taking all the stress, absorbing shocks. That toughness lets them do things like power loops, those really intense flips and rolls. And being lightweight, that's pure agility. It's absolutely fundamental, not just a shell.
Right, okay. So you can't really skimp on either lightness or toughness if you want that aggressive flight style.
Pretty much, yeah. If it's too light and flimsy, it might flex under load or just break on a hard landing or crash. Makes control sloppy.
Okay.
And if it's too heavy, even if it's indestructible, well, it won't have that flickable, agile feel thereafter. It's always a balancing act.
Makes total sense. So you've got this strong, light frame, ready to take a beating. Now you need the muscle, right? The power to make it, like they said, rip through the air like a missile. So let's talk motors, and crucially, the controllers for those motors. They mentioned 2306 motors, high torque, but they also learned the hard way about managing that power. That's the ESC, the electronic speed controller. And they even brought up a past smoke show incident, which sounds pretty dramatic.
Oh yeah, that smoke show. It's a classic builder story, really. And it perfectly highlights why the ESC is so important. It's basically the translator between the flight controller, the brain, and the motors. Tells them how fast to spin. So their choice now, a 45 amp BL Hilly 32 ESC. That's significant. BL Hilly 32, that's advanced firmware, gives really smooth motor control. And 45 amps, that's more headroom, as they put it, plus better filtering. It's all about preventing another one of those fiery failures.
Right, headroom meaning it can handle more power spikes without frying itself.
Exactly. And what's interesting is how they connect that choice directly to the flight controller they were planning to use, an F7 flight controller. That's a faster processor, handles complex calculations quicker. So you see, it's not just picking a good ESC, it's picking an ESC that works well with a flight controller. It's a deliberate pairing for performance and reliability.
Okay, so that partnership, ESC and flight controller, crucial for keeping the magic smoke inside the components.
Precisely.
Now, what about the pilot's view? Seeing where you're going seems kind of important, especially at missile speeds. This is where the video system comes in. The source seemed pretty set on the DJI O4 Air Unit. They were raving about the crispy HD feed and no breakup. Big contrast to the static snowstorms they apparently dealt with before. But they did admit it's pricey.
It definitely is. That's the big hurdle for many builders. It's a significant investment. But the value, I mean, the clarity and the rock-solid link it provides. For precision flying, high-speed stuff, it's almost a requirement now. You just can't fly confidently if your video feed is breaking up or full of static.
True. Hard to dodge trees you can't see clearly.
Exactly. And here's the key insight from their chat. They weren't just thinking about this drone. They saw it as an investment because that O3 unit, they can move it to other builds later on. So it's more like building up an ecosystem of quality parts, not just a one-off expense, a long-term view.
Ah, that makes the cost a bit easier to swallow, I suppose. Thinking long-term. Okay, frame, power control, vision. What about the fuel? The batteries, LiPos. The discussion brought up a direct comparison, 6S versus 4S.
Yeah, and they landed firmly on 6S. No real hesitation there.
Why 6S? What's the advantage?
Simple answer they gave. More punch and better efficiency. 6S means higher voltage, which translates to more power available instantly, and often slightly longer flight times for the same capacity because the motors draw fewer amps. Of course, it demands respect. That extra power, well, hence their joke about trying not to yeet it into the ground at 100-mile RI.
Yeah, that paints a picture. Shows the kind of power you're dealing with.
It really does. It underlines both the potential and the risk.
So, when you kind of zoom out and look at everything they discussed, what's the bigger picture here? It's obviously not just ordering parts online and clicking them together. There's soldering, figuring things out. They even mentioned dividing up the work, one person tackling the flight controller, the other the ESC wiring. It sounds very hands-on.
Absolutely. It's a deep, involved process. Problem solving is constant.
And that toast they mentioned at the end, to another drone that'll probably crash in the most spectacular way possible, that says a lot, doesn't it? It's like this mix of serious technical effort and just accepting that things might go boom.
That's a fantastic point. It really highlights the iterative nature of this hobby. You learn from the crashes, you learn from the smoke shows. Each failure informs the next design, the next component choice. It shows collaboration too, like you said, sharing the tricky bits. And underlying it all is this, well, this passion for pushing the limits, right? Even knowing the risks involved. Spectacular failure is almost part of the appeal sometimes. Which makes you wonder, what really drives that constant push for more performance when the stakes, at least for the drone, are so high?
Yeah, that's a great question. The drive is definitely palpable. So just to quickly bring it all together for everyone listening, we've seen how crucial each piece is. The strong yet light carbon frame, those torquey 2306 motors, the beefier 45A ESC paired with that F7 flight controller to avoid issues. Then the clear view from the DJI O3 fueled by the powerful 6S LiPo. It really shows how every single choice these builders made feeds directly into how that drone flies, based on their own trial and error.
Exactly. It's a whole system working together, built on experience. And maybe, for you listening, the thought that you want is this. What can we learn from this? From this cycle of iteration, this way of balancing risk and reward, this dedication to mastering a really specific niche, can we apply some of that thinking, that focused pursuit, to other parts of our own lives or work? Something to consider.